a little disadvantage after seeing these two great presentations by great minds, Premnath sir and Ratan. I'm just a structural engineer, and what we saw just now was expression of creative minds and very beautiful buildings. And structural engineers are just solution providers. We may be creative in our mind, but our job is to provide solutions to the challenges. And you threw a challenge, Premnath sir. I'll talk about it and I'll answer that challenge also. But today my topic is very small, slight hint how to go about steel buildings. Because let me first tell you who we are. Not working? Oh, thanks. Okay, we are a structural engineering firm about 45 years old. And some of the pictures that you will be seeing will be very old. This is 1982 Asiad Games in Indraprastha Stadium. We show this slide in every presentation. We are proud of this structure. You can see the form, beautiful, symmetrical, architecturally, what we call driven. And any architectural mathematical form is just Badri said. I mean, it's just self-standing, and we have to recognize its potential for stability and strength and use it. That's a structural engineer should do. So this is what it is. This is ICICI Bank at Hyderabad, one of the largest office buildings in India. I don't know whether it is in Asia. It consumed about 32,000 tons of structural steel, and a very large building. You can see some boring pictures as well. This is a night view when it was being constructed. Through the railway station, you saw one picture earlier. Another slide. IMAX Dome at Vada. I'm showing some very few special buildings that we have done. In a span of 40 years, we must have designed at least 300 large, important structural steel buildings. It's difficult to show all of them here. This is one of the new buildings, Peninsula Business Park at Parade. Crossroads 2, that is in front of Mantralaya, has a lot of structural steel in it as well. The National Sports Complex at Worli. Very early buildings, stock exchange. This building used a composite column construction, and in those days we had used steel blooms, 8-inch by 8-inch solid steel bloom as an embedded section in this building. Very difficult detailing to connect the steel beams and columns. ICICI headquarters at BKC. This is again MMRDA building, very unique concept. You may not realize this is a composite building. It has a very classical architecture, but it is composed of composite columns and steel beam, deck sheets, all those things are there. PSL Holdings, these are the manufacturers of steel pipes themselves, so they wanted to build their own building in steel. And this is a very well-known building in Mumbai now at Dadar, Sunshine Tower. You can see during construction, floor plate, the bracings. So, we can make some details like this. And this is how it looks. The architect fortunately wanted to express the structure, and we were happy about it. JK House, it also has a composite construction in it. Mukesh Ambani's building. The annex of India Bulls, they're all built in structural steel because the building premises were up and running, and they didn't want to disturb the premises with RCC construction work. And this is a very unique auditorium that we are doing for Adani Corporate House at Ahmedabad. And this is the latest that we are engaged in, Dhirubhai Ambani Convention Center, involving about 20,000 tons of structural steel. So, having established my credentials that we are into steel, now I want to say something which is a very small point that I want to make. Steel as a structural material is presently used in some areas like large span roofs, some iconic buildings, yes, which are promoted by government organizations like SEDCO, or railway stations are there, convention centers are there, but somehow its use is not as much as the industry wants it to be in housing sector, commercial sector. There are very few buildings, office buildings or residential buildings, that are done in structural steel. And why? So I think Mukesh also is engaged with me with some promotion of structural steel for residential and commercial buildings over the last few years. And from that we have got some learnings. This is again boring, everybody talks about it, but one most important thing that I learned in advantage of using structural steel is value after completion of building life. I mean, no one has talked about it so far. But some of the developers themselves, I mean, it's money, you know. Those things we structural engineers and architects may not realize what is important. In order to promote anything, you have to talk about money. Developers know money. So he told me this concept, value after completion of building life. You build a building in steel, it may last for 100 years. When I started my career, the steel was 4,500 rupees a ton, and it's 10 times today. Now, if you sell steel in scrap, you will probably get 8,000 rupees. If somebody had built, or if I had designed a building 30 years ago at 4,000 rupees a ton, today I would have received 8,000 rupees if that building was demolished and that steel was sold. Building completes its life. It pays for its usage, and when it's demolished, you will get more returns. So it's an investment. So this important aspect was told to me by a developer himself. So let's think in those terms while promoting steel manufacturers, steel vendors. Let's think about this. Disadvantages, of course, again, this has been talked about. But most important thing I find is steel needs a disciplined geometry. Now, is this a disadvantage? Yes, it is. I mean, there are very few architects who understand steel. Like Ratan showed us a very fantastic sculptural building, but he understands steel. He has a geometry in his mind, and that helps Badri to design those. I mean, he didn't have to do any structure. He himself said that. He had to just follow the form. He had to follow the architecture, and the building stood. So, not all understand this. There has to be a disciplined geometry for designing a steel building. And that's a disadvantage. Not many people can do that. And then there is the last one, synergy with, not the last one, disciplined geometry. Okay, it's not here, but that's the point of my discussion today. When it comes to the cost, you can see that structural steel, this is a typical pie chart of a common steel building, let's say commercial building. You have composite columns and steel beams, deck sheet, pour concrete on top of deck sheet. Only the foundations, maybe retaining walls if it has a basement, those are in concrete. Now 55% of cost goes in structural steel. Add to that the cost of deck sheets and fire protection, it's about 70%. Now this is where the problem is, and this cost is prohibitive. The cost of steel is very costly. To achieve a desired performance out of a structural member, if you design that member in concrete and the same in steel, steel will be quite costly. And that's the problem. So, what do we do? First of all buildings cannot be designed in steel. That is the truth. There is a certain class, like I said, geometry is important. Only some buildings can be designed in steel, and in some of those buildings also, not everywhere you can use steel. You can build a component of that building, part of that building in steel. You have to identify that. And in order to learn these things, structural designers and architects have to think steel. They have to, this is what we do. For every building, every proposal that comes to us, we try to make an alternative, structural alternative in steel. And still, we see that even if we produce all the alternatives, make comparative statements, the success rate is very low. So, what is our approach? We say that the entire building need not be in structural steel. So we identify parts, like columns can be composite, they are still encased with concrete. Floors could be flat slabs or steel with deck sheets, you choose. All these combinations, you can go on trying and arrive at a proper combination which appeals to the developer, who says that, okay, for this combination of elements, RCC and steel, the premium that I'm going to pay, it is anyway costlier than a concrete building in today's market. But for that small premium or big premium, if he equates that premium with the advantage that he is going to get otherwise in terms of time or anything else, then he will probably go for steel building. Otherwise he will not. Today, the market in India is still driven by economy and nothing else. Venkat and Khaled showed fantastic buildings, and Premnath sir asked, can we do this in India? I think the time is not there. It's right now, it's all about economy, and unless we make things happen in terms of reducing the cost of the building, people will not be interested. Not that we don't have talent. We have talent. In fact, most celebrated structural engineers are all Indians and Asians, like you showed. Even today, there are some very fantastic structural engineers. I am working with Abdul Razak, who is a Lebanese structural engineer, world-renowned person who designed Burj Khalifa. So it's not that we don't have talent. We have creativity, we have imagination, and whatever challenge you throw, sir, Indians will rise and take it up. So the problem lies here. Now my presentation begins. The tendering process, there are three competitions, inherent competitions. First is architectural design. World does not know when a developer goes to an architect or goes to two architects or three architects and calls for ideas. And there the brief is given to architect about the area usage and what is the purpose, what is the function and all that. And the architect does plans in absence of any information about who is going to build the building, who is going to be a structural engineer, what kind of soil there is. He is not aware. And he produces very good plans and images, and that competition, from that competition, one architect is chosen, and then there is a second competition. For the given architectural design, now a structural engineer has to come up with an economical solution, structural solution. He has no freedom because the 8 80% of the architectural design is governed by rules and regulations. The spaces cannot change. So I cannot have a squarish column instead of a longish column, because then the area is sacrificed. So all such constraints are given to a structural designer, and that is competition number 2. He has constraints. Probably the owner may go to one structural engineer, another structural engineer, or he already knows who can give a very economical structure. All that happens. And the third competition is contractor selection. Here again, the design is given to a contractor. And somebody just gave me a very nice phrase today. We are used to comparing apples with mangoes. But now he said, don't say that. Say we are comparing fruits with vegetables. So now we are going to compare contractors. We do not know what are the resources within. Every contractor has resources. We have some very big contractors in India. But what kind of equipment do they have? Is our building suitable to be built by a particular contractor? We don't know. There is a lack of competition in India. All the time we think of a contract of more than 2,000-3,000 tons of steel. We think of only 4 people. And they are locked with their own resources. They are not interested in hiring any more resources or purchasing more equipment, because there is no steel market in India. Okay? So we are, again, that's a constraint. So now we are going to compare one contractor with another who is not apple and who is not mango. So that's the next problem. Naturally, the prices will be not as expected. So that's the nature of our competition. Generally, a tendering process in such case, after appointment of architect, this is a data. Actually, I have studied so many projects in our archives. It takes about 45 weeks from appointment of architect to appointment of architect after the competition, architectural competition, remember. There could be architectural competitions going on for 2-3 years, who knows. But 45 weeks is the tendering process, in which actually nothing happens. The designs are produced on some sketches, quantification is done, and it's tendered out. No drawings are available. Contractor doesn't get to see a frozen plan, frozen section, forget connection details and all that. He doesn't know. Quantities are calculated on the basis of thumb rules, kg per square meter or whatever, and those are dumped into the BOQ. And that is how the tender is floated and quoted for. Now that's a problem. Now I'll come to a case study. Having said that, we had some opportunities to work on with some contractors who came to us and said that they wanted to provide alternatives to concrete designs, already designed or under designed, being under designed, to some developers, and they wanted to compete with RCC buildings. So this was a good opportunity for us. We designed many buildings, and this is a thought that came to my mind. Let's see the case study. This is a case study of a building about 15 lakh square foot of area near Delhi. So I'm mentioning Delhi because it's zone 4. It's a tall building. You can see 34 floors. One tower is going high up. And you can see the graphics. I took a lot of pains to have that background. I was afraid it was not going to come there, but I'm successful. As usual, as if it is a usual tender, we went ahead with designing a steel building, composite columns. Of course, foundations, raft, retaining walls, shear walls, we took in RCC. it's a very slender building, so we had to depend on RCC shear walls for lateral resistance. Beams would be in steel at all levels, staircases also in steel, slabs, deck and concrete, so perfect steel building, okay? And then of course studs, fire retarders and anti-corrosion reinforcement, all those items are there. And this is a general plan of the building. You can see, this is one tower, 34 floors. This is another tower of 21 floors. This hatched area is a 7-floor podium structure. It's all office building. And the white portion stops at ground level. This is a general, and this is a section, the smaller tower and bigger tower. So when we started the design, as I told you, these are the components, steel grade FE 460 for columns and 355 for beams. And of course we used the UB-UC sections, not ISMBs. We did some optimization studies. One of the exercise that we did, one beam in the bay and 2 beams in the bay, 3 beams, and which combination gave us the least cost, because as the span reduces, even your deck sheet cost reduces, the thickness reduces. So all this we did and arrived at some optimum configuration as thought by us, consulting engineers, okay? Remember this. We went into detail. Remember, this job has come to us from a contractor. And if he gets the job, he is going to build it as it is approved by the developer. So this is an analytical model. We did detailed analysis and came up with all sizes. Did quantification very in detail. All columns, beams, RCC, everything. And we came up with a very nice figure of 1,350 rupees a square foot for structure. We are very happy. What a design, very efficient design, structurally very economical. But what happened? When this data went to the contractor's office, they said, what is 1,350? We have our own costing system and our figure is coming to 1,530 rupees. I thought they were making a switch, some mistake. So I asked them, is it 1,530 or 1,350? They said 1,530. So I was interested, curious, why? So I went there to their office. We sat, we had meetings, and there were regular meetings happening. The first meeting we were only, when are you going to give the drawings? Now you are giving the drawings, when is the BOQ coming? All that sort of thing. But after we gave this first BOQ, then the real meeting, the real interaction started. And then they told me that 460 grade at that time is difficult to procure because the project is fast track and it will take time and all that. So in order to bring that cost 1530, naturally the meeting started. First comment was change the grade of steel. It is cheaper as well as it is easy to procure. Self-compacting concrete I had used because I know as a consultant I face a lot of problems in composite columns with embedded steel and the reinforcement around. So I had specified self-compacting concrete. They said no, don't use self-compacting concrete. But they assured me, as contractor, they will ensure that the quality of concrete will be good. So I took it because they are my clients and if they say so, they will do it. Third was rates. As consultant, I had some notion of, item rates. But they pointed out that fire protection rate assumed by me is quite less. They have actual quotations with them. So fine. Same thing for deck sheets. They had quotation. Then comes rate of steel fabrication and erection. It is also too less. Now, I had assumed a certain rate, which I had seen in some of the tenders. on the basis of which contractors have actually grabbed the jobs. But this contractor said, no, that doesn't work. So we went through, various things, items, point by point, and I was literally convinced why my rate was less. They had so many things on their agenda, It's material cost, purchase, import, transportation. In fabrication, there is storage cost. There are equipment, energy, water, labor. The list is big. Then there are taxes. Octroi, there are two STs, I don't know. One must be service tax, other something. But excise and work contract tax and income tax. Then overheads, environment, I don't know what environment is. It can mean two different things. But that cost is there. Health, safety, insurance, all these things are there. And if all are added, the cost goes to up to 100% of the material cost or more than that. Now this is just unimaginable for a structural consultant. And all these were valid costs. They had experience, they had the rates with them, they had working, everything was with them. At the same time, I told them, boss, I have my problems also. They said, fine, we have got so much cost, now can you reduce your quantities? I said, I have got these problems. I got code to follow. There's a performance criteria, deflection and acceleration and all that. Contractor doesn't know acceleration. Probably he doesn't stay in a tall building. He doesn't know how the building sways. But I have to follow it. Then there is headroom, very important issue in steel buildings. Column spacing, of course it was given here. All these things I have to follow. Damping, steel building sways quite heavily, we have to dampen it. So all these things I told him. So then we decided we should come to a compromise. These things should also be followed and we have to reduce the cost also. So, fine. I'll go back to that slide where they give me these comments. Change the grade and see point number 6. In order to have simultaneous activities, replace steel beams at B1, LG and UG with flat slabs. Okay? So we are trying to reduce the steel component here. Goes well with architect as well as structural engineer. Client doesn't bother. He has given a brief to the contractor that he has these functions, he has this budget and he has this architecture. Now do whatever you want. So now replace basement 1, LG and UG with flat slabs. That incidentally cuts cost also. Cost will reduce. Time, remember, in basement you have to do foundations and draft and retaining walls and then start your composite columns from foundations. All that in any way is going to take some time and the fabrication is going to take equal amount of time. And if you want to wait for steel column to be fabricated and then erected, there could be some time gap. Now, by going for flat slabs in the basements, this gap could be filled up. The building could go up to ground floor. So that was a very nice suggestion coming from a contractor. So, this is the sketch. You can see now the lower 3 floors colored green, they are in concrete. All red ones are in steel now, the columns as well as the beams. The yellow ones are the shear cores in concrete. I came up with a cost, again detail analysis and all that. And this time the cost is how much? 1350. No big change. There's no big change. But the reason was, although some quantity is reduced, the rates went up. I took contractors' rates. Remember, my quantities have reduced, but I have taken higher rates provided by the contractor. Okay? So now, this is the state of affairs, no change in cost. What have we gained? We have gained in time. Okay, so we had further discussions. Another set of comments from contractor. As we have changed the flat slabs in the basements, why not convert the composite columns in the basements also to RCC? Again, good suggestion. I mean, why wait for that small component of steel while you are doing flat slabs? Even that needs some time for fabrication. So change the composite columns to RCC columns. That was also very good idea. And at the higher level, this was our idea, at higher level where the forces become less, we could remove the composite columns and replace them with concrete. So now you can see the lower zone is completely green except the towers. Towers still have the composite columns, but on top 3-4 floors we converted them into concrete. There was another suggestion, change the grade. I mean, this was our suggestions. Concrete grade for column encasement and shear walls changed to M50. Earlier it was M40. This was in order to reduce the reinforcement cost. So we changed the color from yellow to green of the shear course as well. Deck sheet was optimized because the contractor himself gave us a deck sheet design which could reduce the thickness of deck sheet. So here again that advantage was obtained. Now the cost from 1350, the cost came down to 1230 or 38. Substantial reduction. Interaction between contractor and structural engineer. Objective is one, reduce cost. Don't compromise on performance. Share knowledge. That is the whole thing. Okay, then another iteration took place. Some small things here and there. Concrete grade now changed from M30 to M35. And we still achieved some reduction in reinforcement. Some shear wall sizes were increased to reduce the reinforcement content. And then we came to a figure of 1203. Okay? Now from 1530 rupees per square foot, we came down to 1203 rupees, which is a very realistic cost because contractor is quoting this to the owner. He is going to build it. Right? So is this magic? No, it is just interaction. So this 300 rupees or 350 rupees reduction was possible through a very positive interaction without compromising on design. When we knew each other's strengths and weaknesses, we knew what are the resources. There was a very good suggestion. I showed you one optimization slide where I had used one beam in the center, 2 beams and 3 beams. And according to our structural calculations, 3 beams, that is 2 meters center to center span, comes out to be most economical in terms of weight of steel. But weight of steel is not everything. There is lifting cost. This I learned from them. There is a lifting cost. Instead of lifting 4 beams in a bay, if they lift 3 beams in a bay, they could save cost, which I did not know. Right? So we have not used the most structurally least weight option in this project now, but we have used something else and still the cost has come down. So this is just to cite you, but the last figure shows the cost of structural steel comes down to 47% from the first 55%. And then of course, as structural engineers, we have to always compare every steel building with a RCC building. We design the same building in RCC with same ETABS analysis and same performance, same deflection criteria and all that. The cost is about 900 rupees. Fair. I mean, Any developer will give that job to that contractor at 900 rupees if it is RCC. Tall building, 34 story, not a problem. But now look at this. What is the premium? If this building was built in RCC at 900 rupees, we are spending only 300 rupees more for a building which is not entirely steel but has large proportion of steel, composite columns and beams and deck sheets. And for 300 rupees, there is a reduction in time of almost 1.5 years. Now this is the equation that the developer will write on the paper. 1.5 years of saving in construction time. What is the finance cost and all other costs, early returns? I mean, he doesn't have to think. He has to go for steel building. There's no doubt about it. But this exercise has to be done like this. For 900 and 1500 rupees, he doesn't think again, he will go to concrete. Because that 600 rupees is a very, very big factor. But 300 rupees is a thinkable factor. It's a premium, but manageable. So, what were the key achievements in this exercise? The mutual understanding between contractor and consultant. The entire exercise, remember, this is very important. Coming to a feasible design in just 45 days. Because the owner is shouting there, I want the quotation, and he has called the contractor to quote only after his architectural design is frozen, and now he is ready with his equipment to do excavation. He doesn't have time. So this is the driving, I am contractor, a commercial man. He will drive us, he will drive me as a structural engineer to produce designs and BOQs and everything. Owner lacks this. Owner appoints us, then he himself goes in so many iterations of designs and cost and this thing, that thing. He also says the bulldozer is waiting there, but it doesn't interest me. Things can change if owner is handling that part. When contractor is handling the part, I'm sure he's going to do it. So that is a change. Realistic cost to be achieved for given architectural intent. Remember, this is very realistic. Contractor is going to bill at that cost. From the original scheme that we will generally give for a normal tendering procedure, the cost of about 11.5% was saved, just like that, because contractor approached us. 23 crores, that translates to 23 crores. Assurance of constructability. If I am floating a tender in absence of good drawings and knowing what it is, there are claims by the contractors, your designs are not constructible, details are difficult, all that. But here, no. When I was giving a certain proposal, contractor vetted it, all in 45 days. When he said something, I vetted it from structural point of view. So there was that synergy. Assurance of time frame with steel building, there is no doubt about that. And the cost is finalized, fixed. There will be no more claims for the owner later on. Developers should remember this. Except, of course, taxes. They are not in our hands. If owner had included architect and MEP engineer in the same team, or he would have asked them to join the contractor, things would have been still better. That coordination which is still balanced to be done later, we would have done it earlier. And if the flexibility of architectural shape and design was left to contractor, I don't mean the contractor. Contractor still appoints the architect. He can have a competition. The owner can have a competition between 3-4 contractors. And each contractor can appoint different architect. There can still be an architectural competition. And that can happen. Similarly, the last one. This was not done in my case, but If contractor comes up with pain share and gain share tactics, if I achieve so much economy, he will give me so much percentage, I'll be more excited, I'll be more, that of course will happen. So what I'm trying to say is, developers should adopt the alliance concept between contractor and consultants, including architects and MEP. Design brief should be quite small, that he wants, the owner should not say, I want to build 30 story or 50 story. Let it be, decided by the team, architect, engineer, and the contractor's team, which is the best, which gives you the most optimum result. A 30-story building could be more economical, or a 50 could be more economical, who knows. But that exercise has to be carried out. And this design build process, of course, can take over at any time. Like in our case, it happened after architectural design was frozen. But it can start right in the beginning at feasibility study or architectural design level, but certainly it should not be at the tender stage level. That's what I'm coming to. Okay, so this is what I wanted to say. And very important thing, if the project is driven by contractor, he can make a major difference to the project, to the progress of the industry as well, as you can see from here. He can define the shape and geometry, again left to architect, but he will guide the architect. That's what I mean. We are not trying to restrict the creativity and imagination of architect, but there will be constructability issues and all those things. Appropriate materials, they have the knowledge, they are in the market. And then a project performance objectives like milestones and all that, because he is dealing with money, he is driven by money, he is commercial person. So he will definitely tell us when what drawing is needed and how it is needed, in what form, he will do it. And of course procurement, he knows best. He can advise owner about the realistic cash flow. So these are all the benefits. Most important thing is, I feel if contractor is involved as a guiding force, then the technology will take off. I'll give you a small example. We design tall buildings, and sometimes we say, tell owner that, okay, let's go for internal tests, because our code doesn't specify loads for such kind of building. We must analyze. That's a cost for the owner. He doesn't see. He says, why do we need it? Okay. वो बाजू वाले इसने बनाया ना 30-story building. He doesn't need. He has not done internal test. Why are you doing? When all these things take a lot of convincing. Contractor, on the other hand, he is engineering minded. He knows if he invests in good surveying, good testing, or good pre-design studies, he may benefit. He will promote these technologies. All these things, lightweight construction materials, he will promote because his cost is going to come down. Although he must have bid a higher figure, in the end, during the project period, he might tell us, no, let's further, do cost cutting. Okay, 5 minutes. And it's lunchtime also. So this will be a definite advantage. And owner's benefit, as I told you, time benefit is the most important one. And he doesn't have to do the design management, which he is engaged in nowadays unnecessarily. Contractor being in the field, on the job, he will do it better. Okay? And owner will have the advantage of having to compare only the finished products and not, small trades. So this is not something new that I'm talking of. There are already professional agreement templates available. I have been personally involved in such alliances on 2-3 projects, and you have seen that things do work properly and owner gets benefited. Okay, there is something more, but now I'll just wind up. Okay, thanks a lot. Questions?
Anybody has any questions?